Yeah, hi all. Once again, good morning and good evening for the participants who have joined from India and from US. So this is Prasanna Manikonda. I have about 10 plus years of experience in total IT, and I have been experienced with a lot of technologies, coming with a lot of real-time knowledge and cloud computing, big data, and especially into Java J2 technology framework. So that's all about myself. So I do a lot of freelancing and IT consulting and corporate trainings as well. So today, let's have a quick walkthrough about what is this big data is all about, and we are hearing a lot of jargons coming up in big data related world. Everybody talks about big data, but nobody knows what is big data. Maybe to an extent they cannot give a glimpse about what really is big data, how much complex is it, and per se how to start the journey to learn about big data. So today's agenda, we'll cover about what's today's objective and how we actually deliver the course, what is our schedule and timings, and how we're going to cover the course, and what kind of contents we are covering as part of this course. So coming to our objective, before I start off the objectives, what I would really encourage you people, so you can stop me at any point of time. I hope you people have a questions tab enabled on your webinar panel. So feel free to stop me at any point of time, or you can raise your hand and ask me any question that actually you have in your mind, so that I'll stop myself and try to clear it out as many as possible. So keep the session more live and interactive, so that many of the people may take advantage and just try to give some kind of more additional knowledge as possible today. So this is the objective of today's session. So we covered the concepts at the end of the session today. You should be able to understand what is big data is all about, who can learn big data, and maybe how big is big data. So what are different categories of data that actually we consider when we are talking about big data, and what kind of really the business value it really generates in adapting towards big data related technologies, and what are the really challenges that actually big data is currently facing about, and how we are actually overcome them, and what kind of solutions currently available in this particular domain. And we'll slowly incline towards what is Hadoop, and how big data is being used, how Hadoop is being actively being used, Hadoop framework, what is the underlying framework behind it. So that's all. So we'll say about what are the kind of benefits, and what are the different something like features at the same time, and what are the different frameworks which are being underneath of Hadoop framework is being utilized. And we'll just see about glimpse about a standard business analyst called Gartner. We'll see about where do we stand on BI analytics and all. So I think we have an Anu will context help for big data testing too. So for the benefit of all, let me just share my screen so that you cannot see the questions that are being asked by many people. So I think if I understand really well, this coming from Anu. Sorry, I can only have your short name. Sorry for that. So this is the question coming from a participant. So is it something testing too? Yes. To answer your query, yes, we also have something called as big data testing. So I can give you some kind of a context when we go to the different challenges and solutions. I can definitely answer your question, Anu. For time being, just hold yourself. So, and mainly, why are we here today? So we need to know about what are the opportunities that's coming in big data. So we'll cover that concepts in a short while. So yeah, this is something kind of good definitions of defining big data. Just read me. From if you just go on Google and just type Wikipedia and talk about big data, this is what is a definition that comes into your internet. So in this information technology, big data is a collection of data sets, so large, complex. It's very difficult to process using existing DBMS tools. The main challenges could be like storage, searching, sharing, analysis, or visualization. So what it really mean when you're defining a big data related problem or a solution is something, right? So we are dealing with some kind of a big data set which can what is a precondition? Okay, just hold my I have another question coming up. There's another question from I just lost his name. Yeah, what's a precondition to attend this session? We'll definitely cover my dear. Just hold your nerves for about 10 minutes of time. Then you can understand what is big data and who can learn big data, all those things we can in a short while. So, like we are defining big data now. So what exactly the big data is all about is something uh, it's not like let us consider a traditional use case. So hope everybody aware of something like DBMS softwares available currently, like Oracle, Teradata, Exadata. So there are many such already defined tools or softwares currently being available on the market, which have been predominantly working immensely in the real-time enterprise developments. But what exactly the big data is all about, and why the traditional systems are not capable of handling those situations. So just if at all, if you want me to give an example, just take an example of let's consider the usage of social networking sites or the kind of user base currently being immensely growing with the time. So when you have such a immense traditional rapidly growing data, so there should be a need of supporting backend infrastructure to support your infrastructure, support your framework, or support your software to accommodate for your usage. So just imagine what kind of infrastructure being used underlying social networking sites like Facebook, or just imagine like a search engine like Google. So what are the kind of different tools and technologies that are being implemented at the back end? It's almost like 99% of all these websites or portals or softwares are already being adapted to big data related technologies to accommodate such a huge payloads or such a huge workloads. So coming to the other definition coming from an IBM. So IBM says that they are mainly like you can categorize the big data into three categories. One, volume. Two, variety. Three, velocity. So what do you mean by volume here is, so we are defining something like when do we call as big data. So when you're saying big data, the data would be ranging from gigabytes growing from gigabytes to terabytes, terabytes to petabytes, petabytes to zettabytes. So there's a huge data that gets into consideration when we're dealing with data. So there is no other traditional DBMS solutions or file handling mechanisms which would eventually help us in terms of anything like searching or analyzing or doing some kind of analysis on top of it and coming with a kind of a business analysis. So you can categorize something like a kind of data which has a volume which is immensely growing from petabytes to zettabytes. So for information, like we have the traditional systems which can support up to a max about 2 TB or 3 TB at the max with the existing traditional systems. So there is another my dear friend who's actually asking a question from Atish. So does DBMS only store structured data? Yeah, we will slowly come to structured and unstructured related classifications, my dear friend. Just give me a couple of minutes time. Sorry for getting a background noise. So as I said that we are defining big data. So big data can be ranging from having different categories, like one is a huge volume characteristic. Second is variety. So what is variety? Variety means it's something like we have whatever data that actually goes into the DBMS related concepts. Is almost like we store the data in terms of rows and columns, or per se we can take it as records. So whatever data that actually gets into this existing DBMS tools, it's almost like it's all structured data. So there's a perfect predefined schema in which the data gets stored. So there's some other things like semi-structured data, like you can take XML or JSON formatted text. So all these are something like a predefined format of data, which is not exactly readable, but is something like those files are being used in terms of exchanging that information across the integrations or interfaces. So coming to the unstructured data, this is where actually the big data problem really resides on, and what big data really solves is this unstructured type of data. What is unstructured type of data is something like you have this big data related concept being widely implemented in many domains. So let's define what is unstructured data. When you say unstructured data, so we all know structured data is something like it's a kind of DBMS or a flat file having some kind of a fixed format. Okay, there's something like name, serial number, like take a typical Excel spreadsheet. So you have something like this. So this is kind of typical fields that actually you see in terms of any DBMS or any kind of a fixed formatted files, where the file size is not greater than something like 1 GB or 2 GB or 1 TB. So this all things can be processed using existing operating system or existing applications or existing tools and softwares which are really helpful in terms of processing the structured data. When it comes to unstructured data, what is unstructured data is something. Take a typical example. I don't know like how many people know about some more concepts on OS. So in OS, whenever you would like to read a particular file, every operating system comes with something concept called as a file system. So for Windows, you have something like FAT32 or NTFS. Take about Unix, you have ext the partition. So all these file system formats are something like how to store the file, how to read the file. This is what actually operating system is dealt with a file system. So whenever you would like to locate a file and read a particular content in the file, there is some concept called as OS handlers are being used. So this is this responsibility to fetch and read or search the data. Okay, so this is something, this is the traditional way of reading any kind of, and every handler, or depending upon the operating system, it has some kind of a limitations. Okay, so when I say limitations, what is the limitation is something like it cannot read a particular file having a size more than 1 TB. You cannot open a file. It says that file is too long, or file is so the size is more, it cannot open. The number of handlers which are responsible in fetching the data or reading the data, it cannot handle such kind of a huge files or single file having size more than 1 TB. A typical solution which many of the people out of box says that split this file into small pieces where a OS can handle. Let us consider OS can handle till 1 GB. So we will, what we'll do is this entire 1 TB file will subdivide into this many small files. And this is how typically we handle a use case where we have a kind of a flat file having a size which has grown till 1 TB, and we would like to read it. A typical example of unstructured data would be something, take a server.log where continuous logging is actually happening. So in this kind of environment where you have a kind of a log file, a kind of, maybe you can take as a shared storage, the kind of contents gets added up for the entire data center. Maybe take a data center monitoring, so wherein you're actually monitoring entire data centers having something like data center size would be about take about 10,000 instances actually being handled. So if at all, if you want to come up with a monitoring solution and your server logs are actually getting increased immensely and you would like to monitor it, when you say monitor, definitely you will do some kind of a concept called as reading the files, reading the servers, reading the log files, and what kind of analytics you actually come up with. Analytics, reports, sometimes we will do some kind of search for a particular string and do some predictive action. We can call it as a predictive analysis. So this kind of typical examples which can fit in terms of unstructured data, where you would like to do some kind of analysis on this particular data, which is something having size than 1 TB, where typically the existing operating system cannot handle the situation. So in that use cases, we will use big data related tools to process it. So let's come to the velocity. So take a velocity means it's kind of how frequently the data is being accessed or being used for analysis. Let's take a typical use case what currently we are currently feeling now. We are actually using a GoToWebinar platform in which we are actually having the training now. Just imagine how the real-time video and audio is going into the internet, and you people are able to hear absolutely as real time. So how streaming is actually happening, what is your backend system which actually being supported. Just imagine, I have been giving this kind of trainings for a very long time. I have handled a situation where the crowd is more than 100, it goes to 1,000 also. The underlying framework that actually comes with a kind of GoToWebinar, any kind of WebEx, there are some real-time powerful tools which provides a very good backend processing streaming interface, take a typical example of YouTube. Okay, how many real-time users actually access the YouTube videos, and how are we getting that information out of it? So what is the backend supporting engine? So this is all typical use cases where they use underlying infrastructure using big data related tools to provide to handle such kind of situations, especially. So some of my dear friends have actually asked me what is the prerequisite or who can learn big data. So this is something you can take it as like big data. The main biggest concept behind big data is implementing Hadoop framework. So this Hadoop framework is basically developed on top of a framework called MapReduce. This MapReduce is basically a paradigm or the kind of framework being used internally by Hadoop framework that can be developed using any Java JDE programming. Especially when you call MapReduce programming is something like, if you recollect whoever coming from developer background, it is as simple as using a collection object called map. Where do we store the information using key and a value pair? The entire concept runs behind this concept called how we store the data using a collection object called map, especially into key and a value pair. So this particular Hadoop API can be developed using Java JDE technologies, .NET technologies, and there's some kind of a scripting technology called Pig, and we can even use NoSQL databases. And whoever coming from business intelligence or analytics background, even they can also use this big data, or who can learn big data related technologies. So this is a right fit for the people who are getting into who has a kind of a backend experience falling under these primary areas. This learning this big data is very simple, and all that you need to just do is just have a focus on how to consume this big data. I can give you some kind of information so that you can take it up. So there's a couple of questions coming up from a participant called Atish. So how about QA people? Yeah, I'm sorry. So why I haven't kept this testing here is definitely yes, but testing is not something like testing always when we call, it's not like you learn big data concept. There is some concept called as big data testing. That testing we need to adapt to kind of a big data testing tools, or there are a couple of suits that actually support big data. As of now, we are not covering those concepts in our curriculum, but still, what is your roadmap in terms of learning big data? What is the roadmap here is, take a typical example and then we'll go back. Okay, so hope everybody knows what is predictive analysis. If not, I'll just give a small glimpse. What is predictive analysis is something like, let us consider typical use case. You're reading a server.log file, a typical database log. A typical database log, in this particular typical database log, you want to see, is there any kind of network exceptions? Say this is, whenever you get this kind of aura exception, there is some kind of a network failure. So you want to know how many such failures are actually happening. Let us consider per day, per week, per month, and per year. So this is what is the statistics you really want to come up. And this particular server log, this is basically a shared server log. This is something of size about 1 PB. You're monitoring an entire data center where you have all database servers, and you're monitoring it. And the server database log has grown to 1 PB, and you're trying to get some statistics out of specific data error with having an exception called error. So whenever we are actually coming up, such kind of a use cases, so typically we need some kind of underlying technologies as big data. We slowly walk through how are we going to use that. But time being, you just come to a conclusion that definitely we need to use or adapt to big data related technologies to achieve it. So in that particular use cases, so definitely we need to write or develop some kind of a programs. In that particular environment, we need to take some subset of data and see whether our program actually is ideal, or test the data set, or take a sample data set. These are all testing tools. This is all testing actually we do it. So before we directly go and run on a production use case or production data set, we take a kind of a subset of data and run through our testing whether our whatever the program that actually we have written is really work or not. Because usually whenever try to run across on your data set, it typically takes about maybe 1 hour or 2 hours or 1 day or 2 days. Sometimes it take a week. If at all, if your data is grow immensely, and the kind of use cases that actually you would like to come up with are growing one by one. So for those things, if at all if you want to come up with this kind of analysis and want to take some kind of a mitigation action, so you need to have some kind of a handful of data through which you will analyze it, and then you come to a conclusion what is the respective mitigation that you are trying to take. So in this particular use case, testing is more involved. There are tools I'll definitely walk through, but as of now, just keep it to yourself. As of now, we are not covering those things, but definitely yes, all the participants who are coming from QA, especially from quality testing, assurance, definitely yes, you have also an opportunity to learn some kind of a testing interfaces. Maybe Selenium has some kind of a testing framework coming from big data. So there are a couple of specially designed for big data related problems, how testing is being used widely across in actually getting into the concepts. So let me go. So we'll see about how big is big data. So we have already covered some kind of a glimpse about it. The big data is something like the data ranges of in TBs and PBs. It's something like take a traffic. So just take some kind of a how many people are actually coming to the internet or coming to online or start using some kind of a social networking sites, and how kind of data is actually growing. So if you take a statistics about 2010 to 2015, so it's actually the number of users who are getting into online have been growing immensely from 3.2 billion to 16 billion. So there is something like there is a huge growth of people who are coming to online. So there is a need of change in technology to address these issues. So if you take big data, is something like you can take something like a summation or a kind of you can take the transactions, interactions, or observations. So the big data, it's not only specific to a particular domain, like it can be used only in a particular sector. It's not like that. It's something like wherever the data, wherever you get some kind of unstructured data. Take example of sensors and RFIDs. I don't know whoever is coming from and electronics development background. So people generally actually play with some kind of sensors or RFID devices. Take a typical example of aviation industry. In a typical aviation industry, you just imagine if an aircraft actually takes off and go in air, if it is traveling for 1 hour, you know how much data it actually generates? For every 1 hour of travel on air, each aircraft will generate not less than 10 TB to 1 PB of data. How this generates is there's a lot of electronical data which gets added up, which gets streamed to the nearest monitoring station to do lot of statistics in terms of doing all sorts of predictive analysis. Okay, some device will tell about radar signal, some device talks about what is your health status on your fuel, some status talks about what are the conditions are currently outside the temperature, take the atmosphere, how to handle the situation, if at all if it is actually going on auto mode, what is the corrective action we need to take. There are a lot of predictive analysis that actually goes in with the kind of data that actually gets from all the sensors. There's a huge, maybe if at all if you talk about some kind of a hottest jargon comes into your internet, says that Internet of Things, IoT devices or IoT concepts. So there is a huge data that actually comes with this kind of interfaces dealing with electronic devices. So the data gets immensely growing from megabytes to petabytes of data. Take any implementation like CRMs, your content management portals, take some web interfaces like search engines. So these are all typical use cases where you have more, the data is getting growing like anything. So this is how you get data. So when we have seen it, what is volume, variety, and velocity, if you can just see the number of users who are getting into the amount of big data stored across the world in terms of petabytes. The storage, take about each continent across the globe. So there is a growth of 3,500 PBs of data coming from US, likewise in Europe and other places. The data is getting growing. Okay, it's actually growing now. So you need to handle, there is a huge potential need of big data related technologies and the developers who can process that information to get some kind of meaningful information out of it. Take a variety of data. So there are a lot of new users coming online, and there is something like different people who are actually interacting with machines, and something like when you are talking about IoT concepts where take about RFID devices who actually communicate between devices, machine to machine. So these are typical variety of segments wherein people start contributing to your growth of your data. And the last thing is velocity. So you have interfaces where for every 1 second there's a huge emails getting exchanged, about 2.9 billion emails sent every day per second. There are 20 hours of video online streaming gets going into any kind of content management systems. About 50 million tweets per day in your using of social networking. There are many live examples. I'm just giving a kind of a velocity, the rate at which the data is getting dumped into your systems. So this is all about classification, categories of volume. As we said, volume, velocity, and variety. I'll just take a pause. So do you have any doubts or are we good? We can go ahead. If we good, we can continue it. We have another 20 more minutes time in actually giving a glimpse about it. I guess I don't see any questions coming up, so I'll just good to go. So as we're saying that what kind of volume? So these are different use cases where the volume of or the data is getting growing. Take a social networking site like Facebook. About 1.1, almost 1 billion users are accessing your Facebook application, and you can just imagine how crazy these people are adapting to social networking sites. You take about people how effectively they use it or how crazy they use social networking sites. So definitely we need to have some kind of a knowledge, right? There's another question coming from Deepa. So is it good to have QTP knowledge to get into Hadoop technology? You are rightly said, because testing is not the limitation. We need kind of good testers who really need in terms of testing. Yes, even some kind of a screen-based testing also needs sometimes in order to do a kind of a sampling. For sometimes we may need to know understand the kind of a flow. So yes, QTP is also the knowledge is definitely can be reused, or people who are actually having QTP knowledge is also preferable to learn big data. So coming back to the volume, so these are different types of illustrations on different segments where people are using or how the storage is getting added. Take about variety of data. You take structured data coming from all traditional systems. So unstructured data from social networking or channels. Take your telephony traffic, data traffic, VoIP traffic. Take about sensor data, talking some kind of machine-to-machine devices. So take about video, streaming data, images, take about GPS. So all these different varieties of data which actually contributes to big data. Take about velocity. So as we have already seen, so the social networking sites, about 900 million users, almost like kind of billions of users are getting logged into social networking sites who are actively using. Now if at all, if you just consider it, Facebook or any kind of social networking site is no more a kind of a fancy tool. It's actually being growing immensely. It's almost like it's a kind of a marketing weapon to broadcast your information within very less time. If at all, if you want to reach a wider audience, then undoubtedly it's only you can possible through social networking. There is another doubt coming from Vinod. What is the question? Who actually have Java experience and can programs with big data for processing big data? Your you your understanding is partially yes, but I don't completely agree. If at all, if you're coming from not coming from a development background, nor administration background, nor testing background, then probably yes. If at all, if you are a fresher, then definitely I'll come to a conclusion where why you should learn. Maybe I'll just keep it as a secret, or to make our presentation interesting, I'll cover why you should learn. If at all, if you're not falling under developer, if you're not falling under tester, if you're not falling under administrator, we will walk through why you should learn. Just give a couple of minutes time. I should be able to disclose that secret. So this is all about, we see that different velocity, the rate at which the data is getting accessed or getting into the systems. So we have about, just imagine, so we have about 7 million users visiting per second. These are all real-time statistics that I have taken it from standard websites. So you just see that what kind of business value it really makes. Okay, take about consulting, take about retail part, take about typically a Walmart. Okay, I think people whoever is attending from United States, hope I think last week you people have really celebrated Thanksgiving Day, and definitely yes, many people would have surfed to internet to check about black deals, Black Friday deals, or any sort of offers. So you want to know, right? So how a particular vendor is actually trying to give the information or broadcast the information so that he would actually come with some kind of a statistical analysis across, maybe take about US, what products I should sell, what products I should give offer, what offer it really makes sense for a particular consumer to come and buy it, where should I sell it? Should I sell it, come to shop and buy it, should I make it as online? So these are all consideration before a particular vendor throws an offer. Am I right? So there are lot many things which actually need to consider to process some kind of an unstructured data. They will take about 1 year or 2 years or 5 years trend analysis to understand how many users actually came to the shop and bought a product, how to promote a product, how to sell a product. It needs a lot of maybe you can say some kind of business analysis need to be done at a backend to throw an offer or to sell a product. Take about any product, take about food. Okay, take about a new product. Let us consider a Pizza Hut is going to launch a new pizza. So it needs a lot of survey, right? They should do a market research. Take about automobile. How much testing a particular vehicle will undergo in order to come a new launch? Take some example of an XUV coming up. So if at all, if a manufacturing industry really want to launch a new vehicle, how much of market survey they will do in order to come with a requirement gathering and freeze what are the main key new unique features I should actually keep into the vehicle, how to attract the people, or how to attract what segment of people. These are all analytics. Okay, everywhere it's all about analytics. Everywhere we talk about processing the data. Everywhere we take consideration from lot of inputs. If you take a new launch vehicle, there will be a lot of marketing sites who actually give information about tweets about particular vehicles. So they take all those websites, they take all those information, they take all those inputs from devices, marketing surveys, news channels, people watching ads, people clicking on some Facebook ads. There are a lot of media in which where you get data gets collected or submitted or people start using it. So they take all these inputs, which mainly can classify as unstructured data, which can the data definitely will be growing not less than PBs. So we will use those big data related technologies to process that information and give some kind of a meaningful data or predict some meaningful data so that there will be some kind of a dollar. So definitely we need to use some kind of a knowledge which gets out of that kind of information, meaningful information. So this is how the typical productivity got increased in different segments by adapting to big data related technologies. So these are all segments, people who are started using big data related technologies. They could see that a lot of potential of growth of data that is being used. Take about trading. So hope many people would have been faced this. So just imagine how a stock exchange website, how the fluctuation of data, how much data is getting processed per second. Okay, take about fraud and risk. So you will be having firewalls for every data center. Okay, whenever you're going to internet. So there is a lot of network devices that actually at backend being implemented. Take about telecom sector. How much of live streaming of data is actually happening? How many people are actually using video calling? So how the data is getting transmitted across different channels or different mediums in telecom industry. So these are all live use cases. So we can say a kind of challenge. So definitely there is a need of some kind of a very powerful backend system which would process this kind of immense growth of data that's actually coming up. This is the kind of challenges or new opportunities in order to process it. That's where we actually use the evolution of Hadoop. So Hadoop is like when we talk about something like it's coming from an Apache community, it's pretty much open source, and it's mainly built on top of Google MapReduce API related concepts, and even Google has also contributed to this kind of a framework. Google and a couple of other people who actually collaboratively came up with this kind of a framework called Hadoop. Okay, there's another interesting question coming from Atish. Where do we actually store the data, or do we use cloud related platforms? Okay, yes, you are right. So we not only use cloud, we use cloud for many things. We use cloud for storage, for processing, for doing analytics and publishing. For every phase we talk about, we'll be using cloud interface for actually having it. So I just skip few slides for the benefit of other people. So this is all about why a Hadoop or why a big data technology actually came into the place, and how Hadoop is actually growing in the market, and what Hadoop does mainly. So when you take about Hadoop, Hadoop is basically a framework which is actually built on top of this paradigm called as MapReduce paradigm that would really used at the backend for any big data related technologies or tools which are implemented. So what are the typical benefits that we can get from using a Hadoop is something. Hadoop actually uses a kind of a distributed file system called HDFS. We'll talk about components shortly. So the kind of benefits when you talk about the kind of distributed computing power, flexibility, fault tolerance, especially low cost, scalability. So there's something like, take a typical use case. Maybe if you can, people coming from a developer background, if you want to have a huge payload coming to your servers, take a typical application cluster, take a load balancer. So these are all typical use cases where you need some kind of a clustering of resources or computing resources which would be needed for processing your heavy payloads. Similarly, if you want to have such kind of environment, we typically will not use traditional desktops. Am I right? So we'll be definitely using a kind of huge servers or compute devices in order to develop such kind of a framework. But whereas Hadoop, why it is low cost? First, predominantly it is basically open source and it is free for users to start consuming it. And this particular framework can be used with the help of a very low level hardware also. It is not typically you need always a blade server, always you need a high-end concept. or you need some kind of a traditional data center wherein you process it. Hadoop can run on a traditional desktop like hardware. You take a typical 10 desktops and you can collate your storage, you can collate your compute, you can collate your all your services, because if at all if you want to use a typical distributed file system or a distributed processing, you need definitely a powerful engine or definitely a licensed product which actually used typically in terms of OS cluster or the database cluster, typical Oracle rack. So you need some kind of a powerful framework that actually backends to process it. But whereas Hadoop, with the help of a low-level hardware itself, you can form such kind of a cluster to process this big data. So today we're not going to cover more concepts on big data. So just understand that Hadoop is such a kind of a framework which can be run on a basic hardware, typically with the help of a basic networking, have about 10 desktops in a LAN, and you can collate the concept. For example, take a typical use case of having every desktop has about uh, 100 GB of, maybe 1 TB of hard disk. So take, we have 10 systems. So when you have 10 systems, it's something like we have 10 TB of, we can process 10 TB of data. Take about each CPU has about a 4-core processor. Maybe you can take processing engine as something about 4 GHz processor. So we have about 10 systems now. 10 into 4. So we have about 40 gigahertz processing compute thing. We have 10 TB of compute, 10 TB of storage, 40 gigahertz of processing compute. So with the help of basic LAN, we can definitely run through test cases which can be processed with this kind of system. Let us consider, if at all, if you want to process more, you are processing a kind of a data set that's actually having more than 10 TB. What we do is typically, definitely we need to add the hardware, but we cannot add the hardware just like that, right? We need to have some kind of a framework to add. So, but Hadoop, it is just like a plug and play. Just add the instance, automatically you'll go into add. Okay, there's another question coming up from Atish. Let's answer him. Does Hadoop work with mainframe? To my best of knowledge, IBM should actually come up with some kind of a framework. I heard some new framework that is being developed especially to process the kind of workloads that actually mainframe does, but so far it is not went live so far. Okay, to answer your question, it's something like it's still under a beta. It is not still gone live. People are really awaiting to do it, but how typically those use cases are being translated, like they use a kind of a underlying database solutions which would get the data out of mainframe, and from their data warehousing systems they push the data onto big data related solutions to arrive faster solutions. So when we're talking about typical use case, so this is how the compute capacity is. It can grow, or you can use basic hardware. That's the reason you can reduce your hardware costs. And this is basically an open source. You will not end up paying license cost in doing this. And second important stuff is you can use any kind of cloud based systems to process this information. So this is how you can typically use any sort of big data related problems using Hadoop like framework to solve your big data related problems. So this is all benefits we can, it's actually self-explanatory. So this is how a typical ecosystem looks like. So we have about Hadoop having two flavors, having 1.x and 2.x. So in 1.x we have typically components like HDFS file system, where I said distributed file system. There's a kind of a master and a slave concept where how it actually does it. So this is how typically the ecosystem looks like with 1.x and 2.x related versions. You have a yarn like there's a new concept coming from 2.x. You have a yarn. You have a resource manager. As a typically you can just if you can correlate, it's something like a master and a slave concept, where a master gives instruction to the slave nodes to how to process information. So this is how typically a kind of a flow, if you just come out, these are the typical ecosystem tools. Hive is basically to have a data warehousing solution which is actually immensely growing in nature. Pig is something, as we talked about, as kind of a scripting. So this is something called as Mahout machine learning. So this is how we will actually we can definitely walk through when we actually start off the course. These are all different tools and technologies that are actually falls under Hadoop framework. Most of the products that comes from mainly from Apache community. These are all open source. Each tool set is actually used for a specific use case. So maybe I'll take one simple example. Take example about machine learning. So how many people actually log into Facebook and see there are a couple of, maybe take about Google as a search engine, maybe take typically, I'll just go it. How many people would have laughed at when you're typing this, okay? Can you see it? When at the moment that we type how to, why these strings are coming up? Why are we getting all these things? Okay. Why? Because these are the queries that are widely being queried in Google. So that is the reason you're getting this kind of a predictive analysis. So how this particular thing are actually coming up? When you say big data, how Google is actually getting this data analytics? Okay, how this particular data is getting fetched from different sources? This is all about big data, my dear. This is all about big data solutions. Okay. Now, interesting part. Okay. Go to Flipkart. Maybe take for the benefit, we'll go for Amazon. Amazon.in. So this something, when you talk about all these commercial sites, all these commercial sites or e-commerce sites will tell you why only this particular mobiles are showing to me. For example, if you log into a particular website, you may be seeing different varieties of products. The reason is every user who visits the website will maintain some kind of a history. If at all, if you search for a product, okay, take about some electronics. Okay, if I just select this, there is some kind of a predictive analysis comes here. So, okay, can you see this? Customers who bought this item also bought this. So this is kind of a predictive analysis. How this particular analysis actually coming up is, it's a concept called as the big data. There is a concept called as machine learning. Okay, using some kind of a Mahout-like technologies or a framework, they does predictive analysis at the back end, and whenever such kind of a products are actually being searched, This is not actually happening at backend. This is something on the spot, very dynamic in nature, depending upon the product that a particular customer actually views it. This is all something dynamic in nature. The moment that we start using it, automatically the backend program will run and fetches the data related to it. How this relation actually happening? How are we relating this? These are all analytics. And this is something where Mahout is one kind of a framework, comes from the big data related solutions, where that really helps a lot in terms of doing all sorts of predictive analysis. Can use AWS with Hadoop framework. You are right. Maybe I'll just give another glimpse of idea. Hadoop, this is basically a distribution, okay? This is an open distribution. Just how we have Unix open source distribution has been taken over by Red Hat community. They have coming up with their own release called as RHEL, Red Hat Enterprise Linux. Typically, Hadoop is an open source. Different distributions currently available in the market are something like there is a community called Cloudera distribution. There is something called as Hortonworks. There's a guy called Pivotal. These are typical, and from Amazon we have AWS, Elastic, MapReduce. These are all enterprise customers, vendors who actually develop on top of Cloudera distributions, on top of Hadoop-like distribution. They have developed something on top of the basic distribution comes with Apache community, open source community, and they have their own flavors. Each flavor has their own new set of features, which are something like very unique in nature. So out among all these vendors, Cloudera and Hortonworks are widely being implemented across the big data related communities. And Pivotal and Elastic MapReduce are something like whichever want to go with those kind of products, they're adapting to those kind of frameworks. So the distribution is something like it's basically depending upon the use case or depending upon where we exactly using it, we'll go with this kind of a distribution. Take about Gartner's thing. This is typically where the products related to business intelligence and analytics talks about. So hope who are coming from a BA background. So Tableau is one such tool which actually making use of big data related background technologies in terms of getting analytic reports or generating dashboards. These are the typical use cases. These are typical products which are actually hot in the market as per Gartner's case study. We don't have any CLI or GUI interfaces for big data. When you say GUI, it doesn't mean GUI directly. Depending upon the distribution that actually we use it. So there's nothing like CLI. You have something like in place of CLI, you have SDK, software development kits, which are actually, as I said, it supports Java framework, it supports .NET framework, it supports Pig. So these are all typical technologies or frameworks through which you actually interact with Hadoop as a framework. UI, it all depends upon the distribution that actually use. Hortonworks comes with a different UI tools which are actually developed on top of some technologies, and they use underlying Hadoop framework to get. Okay. So coming to the case study here. So Gartner is one such business analyst who actually does a lot of magic quadrants. You just go to Google and search of any domain that actually you talk about. Go there and actually say that Gartner magic quadrant. So you get a lot of reports as this kind of a quadrant, how it looks like. So you need to concentrate wherein you see that a lot of I don't know, this pen is not working. So typically you can see these products are actually hot in the market. Take about industries. So this is where actually if you take a spread across the kind of industries where people are actually hiring big data related experts. What about MongoDB, where it stands? MongoDB will cover something halfway through. MongoDB is a kind of a NoSQL related database implementation. We'll definitely use in terms of processing data related to NoSQL related part. This is something for the people who really want to know what is big data, or where this big data being used, or where I can myself can be hired, or what kind of burning opportunities for this big data related experts. If you take about, these are the potential areas. Okay, so there's a huge demand about hiring big data related expertise. Take about market salary. Maybe this is money. It is not fancy. It is very realistic standards. This is how typically the salary would really range for a big data related engineer, which can go up to 130 plus K. And these statistics I have taken with 2014 statistics from a site from, I think it's a well-known site called Forbes. Forbes community actually gave the statistics. These are the published statistics from Forbes reports. And these are the top 10 data, like top 10 big data employers as per statistics of 2014. So Cisco, IBM, Oracle, Intuit, Amazon. Hope many people would have heard about these big giants, employers in the market. So there are the potential players which are actually consuming big data related experts. So I'll just pause here. So whoever are not coming from a developer background, nor administration related background, nor from a testing background, and still you want to know why you should learn. So this is where actually the opportunities really make you to show interest. So I just pause here. So any questions? We'll have a quick 5 minutes of discussion. If not, then probably I'll walk through about how exactly we will deliver the course and what are the different contents we are actually covering as part of this course. I'll just pause here. We're actually running ahead of time, I know. So you can, if at all, if we have no questions, we will definitely move ahead. I don't see any questions coming up. Can you please share the note? Definitely yes. I think Manoj from my team, who has from my side, is the central point of contact, who will distribute this presentation. You can definitely take it. So with that said, probably we'll just move ahead with other slides. This is how typically we will organize our trainings. So we have our trainings coming up from Monday to Friday. We schedule these trainings for about 1 hour daily, typically from 7:30 a.m. to 8:30 a.m. IST, Indian Standard Time. We will definitely schedule in EST hours even. So depending upon the turnaround ratios and availability of associates, we will definitely tweak our timings. We are pretty much flexible enough. So how we actually deliver it, probably whoever are the first timers to IT eLearn, people are something like, we will broadcast or allow first 5 sessions. You can enter for free and you can have a feel about it, how we actually deliver the training. And from next onwards, we will actually allow only for the paid members, which I mean you can need to pay the subscription fee for this course so that you can allow for taking up other modules. So coming to the contents, this is how we actually categorized it. But as of now, tools are not covered as part of this course curriculum. We will cover those tools concepts maybe in the next coming up modules. As of now, we are only covering developer, administration, and ecosystem. This is typically our course curriculum talks about. And trust me, like we will definitely cover all sorts of real-time concepts and real-time examples. We can definitely work through it. Some programming, okay, is it mandatory to know programming? What we can do is for the benefit of all people, definitely we will try to cover the basic concepts on Java J2E technologies. Whoever are something pretty much new on Java, we'll probably cover about 1 day or a 2 day kind of a quick maybe a brush up or a kind of a how to start the journey. We'll give some kind of a power pack on that. Probably with that, probably we should be able to get some understanding on how exactly we use it. If that makes you interesting, you can continue the topics. Maybe for the benefit of others, we can actually continue it. I'll guide you through how to start your journey in big data. You haven't mentioned about the testers in your previous screen. Yes, testing is not part of our curriculum as of now. So we are still defining the codes for testers. But trust me, like what we exactly we are covering for testers is something like whatever we do as part of the use cases are concerned, we will take testing is also part of the delivery so that we will cover those concepts, because definitely we need not only big data developers, we need big data testers as well for to know how to test the solution. So without having a testing in place, we cannot go with any kind of big data implementations. So definitely, yes, we need some kind of a testing knowledge as well. So any questions? If at all, if we don't have any questions, we'll wind up. Yeah, we are almost close to the. Sorry for taking more time, but I think I made productive. So here we go. So if at all, if any questions that you have about the session, please leave a feedback and please get in touch with Manoj, who would actually coordinate for this course. Please come up with your registrations, doubts, we should be able to take up in the next coming modules. So we'll definitely keep watching our IT eLearn website. We will broadcast when we are actually going live with the course. We'll go with about first week of this December. We'll go with a few more orientation sessions like this. You can invite your friends or guests who are really want to get into Hadoop. So we'll actually go with some kind of more orientation sessions like this actually happening. After few orientation sessions, we'll start up the course, maybe in the mid of December. So keep watching IT eLearn website for more updates on this course, and you can start registering yourself for having more information about this. So thank you one and all. I have another question, one question coming from a participant called Sharmin. What can Hadoop add in testing career? What can add? So if at all, if you want me to answer this question, what can Hadoop add in testing career? Maybe I will give you a very diplomatic answer here. Testing as such, when you take as a domain, so it actually, you need to adapt or you need to grow as per the industry demands. Take as something as a kind of a journey in testing. People would have started with manual testing. Now, no more manual testing. Everybody want automation. So people would have coming from manual testers, they would have actually gone to automation testing using QTP or any other screen-based testing tools. There are many wider spectrum of automation testing tools actually currently in the market. And from there, they actually start moving into different industries, different domain-specific testing tools. Now coming up with open source testing tools like Selenium. There are some dashboard reporting tools, testing tools, and now it's something like a time to learn for big data related testing tools or frameworks to test especially for big data related domains. So when you say testing, definitely you need to carrying with some kind of a business domain knowledge. If you're actually coming from BI or business intelligence or coming from electronics or from manufacturing, wherever you are, definitely every domain needs big data related adaptability, and slowly they're adapting to those technologies, and there's a need of big data related scientists. Definitely, yes, there is a scope for the tester also to be getting into the picture to take your own opportunity. That's all I can say. Do we have automation testing tools? Yes, we do have automation testing tools. Probably you can just browse the internet. I can help you in the course duration. Yes, do we have we also have some kind of automation tools. I'll just pause here. I'll just take one call. Okay, just 1 second. I'm getting an important call. Yeah, I'm back. So any questions? Or are we fine? Looks like we are not getting any kind of questions. Please get in touch with Manoj. I'll share across the presentation, or you can check in the IT Elon websites with the pre-recorded session so that you can definitely go through this video. Manoj, can you wind up the session for today?
Yeah, thank you, Prasanna. Thank you, team, for joining the session, and we'll inform about our upcoming uh, sessions. Keep watching ITLN website. Thank you for joining today. Bye for now.
Yeah, thank you all.